Assalamu alaikum viewers. In this video we will learn about the most important basic topic of quantum mechanics, that is about the operators. Operator is something that operates on anything and changes or leaves it unchanged. If we ignore the trivial case of identity operators, we can say that operator is anything that brings a change, that causes a change. We can relate it to a very common example of our daily life, that is a flour milling machine, in which this machine operates on the wheat and converts it into the flour. It is the operator that makes something more valuable, as in our case the Hilbert space is just a mathematical set of operators until we perform a transformation over it, which converts its element into the scalars of the field, or which connects both these. And it is these transformations which makes the dual Hilbert space, and it is the dual Hilbert space which makes us enabled to define a scalar product. And we know the scalar product definitely has a meaning. For example, the scalar product of a vector with itself gives the probability of finding a particle in a certain region of the whole space. Now we come to the definition. An operator in quantum mechanics, we represent an operator just by putting a hat over the symbol or the letter of the observable. It is a mathematical rule. Why we call an operator a mathematical rule? For example, if we have a differential operator, a derivative operator, which gives a small change with respect to the independent variable and the dependent variable, but it operates according to some mathematical rules, for example power rule, quotient rule, and how it operates on exponential function, how it operates on logarithmic functions, how it operates on the sum and the difference. So it operates always according to some mathematical rules. Even it gives a change, a small change, but it operates according to mathematical rules. So there are many operators, instead of calling them separately by names, as all of these operate according to some mathematical rules, so we call them overall as mathematical rule. When applied on a kit psi, changes it to another kit psi prime of the same space. Is you can understand it by a very simple example, that this wheat and flour, which linked by this machine, both belongs to the same types of grains. So here is also the same case, that the kit psi on which an operator operates belong to the same space is that kit psi prime belongs. And when applies on a bra phi, transforms it into another bra phi prime. That is, when operator denoted by a hat operates on the state vector psi, it converts it into the sign prime, and similarly bra phi into bra phi prime. A similar definition applies to the wave function psi of vector r. That is the wave function or only in the position space. Exactly the same case, when a operated on psi, it is converted into psi prime, and when on phi, converted into phi prime. Now we will discuss some examples of the operators that we study in quantum mechanics. Here are some examples of operators. First one is the most obvious case. As we know that in case of an equation, an algebraic equation, ax plus by plus c z is equal to for example 0. This equation has many solutions, but it has also an obvious solution. That what does we mean by the solution is the values of these variables which must satisfy this equation. So zeros are the obvious values of these variables which satisfy this equation, which is called the trivial solution. And we know that the non-trivial solution is much more important than the trivial solution. It is just the obvious case. So similarly here, first of all we discuss the obvious case of identity operator. It does not change the identity of the state vector or anything on which it operates. Second example is the gradient operator. Gradient, it is an operator which gives the change with respect to the different grades. For example, the temperature of the different layers of the same room. And how does it operate? It is equal to partial by partial xi hat plus partial by partial yj hat plus partial by partial zk hat, and it operates as it's every we find the change with respect to every independent variable in the system state phi on which this differential operator operates. Number 3, linear momentum operator. We know that linear momentum is just a combined effect of mass and velocity, but as we discussed earlier, that in quantum mechanics we mostly deal with the operators, and we define an operator just by putting as we represent the linear momentum by p, and we define the linear momentum operator just by putting a hat over the symbol or the letter of this observable, and which is equal to minus iota h bar del hat or del operator. So p operates is just like del operates on the vector psi being multiplied by minus time iota h bar. Number 4, Laplacian operator. Laplacian operator is just the scalar product or dot product of the differential operator, which is obviously a vector quantity, and we know that the gradient always this operates on a scalar function and converts it into a vector quantity, a vector function. So we can define a dot product, a scalar product among this differential operator because it's a vector basically okay. And how does it operate? It is equal to the square of each differential partial square partial x square plus partial square partial y square plus partial square partial z square. And how does it operate? Just like the differential operator said, it is the Laplacian operator, and that alone one time differential operator is just the gradient operator. And next one, which is the most important one, is the parity operator. It is, what does mean by the parity? What does mean by parity? A parity is the reflection through origin or reflection followed by 180 degree. It consider this arrowhead with some length as an object, and imagine that here is a mirror which reflects this object exactly at the same distance from the origin, which is just a reflection of this object. Here we can see in the mirror, if we rotate this object, this image, this reflection by 180-degree, now this reflection is called parity. That is the reflection now passing through origin, and it is such an operator that inverts the space coordinates, and it is also called space inversion because it inverts it gives inverse of the space coordinates. That is, it when appears an x makes it minus time x, and when appears an y minus time y, and z gives minus time z. Parity operator, we apply the parity operator basically for knowing that whether a function is odd or even. If it's after operating the parity, we get, for example, we operate parity operator on psi of r, and we get psi of minus r, and then finally minus comes out, retaining the wave function as it is. Then we will call it, as we get minus after operating the parity operator, so we call it odd quantity. And if we get plus positive here, then we say that it is an even quantity, even function. So this parity operator, when operates on the spherical polar coordinates, it does not change the length r basic without an arrowhead, is the magnitude of the position vector. So it does not change the position length of the vector, and it changes the direction. So theta and phi both represents the direction, azimuthal and polar direction. So it converts theta into pi minus theta and phi into pi plus phi. But how? For example, this is our y-axis, this is our z-axis, and this is our x-axis, and we have a position vector r whose magnitude is equal to smaller, and which defines an angle phi with the polar axis, and we get its projection on the xy plane, which makes angle theta with the x-axis, positive x-axis. If we apply a parity on the state in this system, which will convert this position, reverse its direction, so we will get an operator r here. Now the z-axis is here, so if we look here, this angle is now pi plus phi, and this inverted position vector projection here will have an angle of pi minus theta with the positive x-axis. So we will discuss the parity operator in complete detail in the topic of parity operator. Thank you for watching the video. If you understand the topic, kindly subscribe my channel and press the bell icon to receive the next upcoming videos. Thank you.